think for a moment about what it takes to feed all the chickens in the world, the ones that end up on our plates.
It's a staggering amount, isn't it?
It really is. And the way we currently produce their feed, well, it has some pretty serious environmental downsides.
Yeah, pressure on water, biodiversity threats, the list goes on.
Exactly. And with global demand for meat just climbing, finding more sustainable ways forward is becoming, well, critical.
Which brings us nicely to what we're exploring today.
Right. A really fascinating challenge.
Absolutely. You highlighted this really interesting study. It looked at a potentially game-changing idea.
Which is?
Could we supplement the diets of broiler chickens? The ones raised for meat. It was something a bit unexpected.
Like black soldier fly larvae and propolis? Sounds kind of unusual.
It does sound a bit out there.
Mm.
But this research investigates how these additions could pave the way for more sustainable farming.
And maybe even healthier chickens.
Potentially, yes.
Yeah.
Healthier farming, which ultimately impacts the food we all eat.
Yeah, what really grabbed me was this potential win-win. Environmental benefits, sure, but also looking at the chickens themselves.
Their growth, their health, looking at their blood traits.
And even the meat quality.
Right. So our mission for this deep dive is really to unpack this research together.
Understand the key findings, about feeding chickens these unconventional ingredients.
And make the science behind it clear and hopefully pretty engaging for everyone listening.
Okay, so let's start with the why. What's the problem with traditional feed that this study is trying to solve?
Well, the paper's introduction makes a really important point. The way we currently do livestock production, especially in many developing countries, it faces some big sustainability hurdles.
And feed is a huge part of that, right? Keeping up with demand.
A massive piece. The need for animal feed is just constantly growing as meat consumption rises. Projections show a really substantial increase coming.
And what usually goes into that feed? Stuff like soybeans, fish meal.
Exactly. Important protein sources, no doubt. But their production has its own environmental baggage.
Like the water needed for soybeans.
Yes. The paper mentions the strain on water use. And
Yep.
for fish meal, the impact on ocean ecosystems, on biodiversity. You can see why researchers are looking hard for alternatives.
Okay, so that brings us to alternative number 1. Black soldier fly larvae, BSFL.
These are the larvae, the juvenile stage of the black soldier fly. Hermetia lucens, scientifically speaking.
And why are they so promising? What's the big deal?
Well, the paper points straight to their nutritional profile. It's pretty impressive.
Packed with protein and fats, like the stuff they're replacing.
Pretty much, yeah. Similar enough to be a viable substitute for what chickens need to grow well.
But it's not just what's in them, is it? It's how they're produced.
That's a huge part of the appeal. The research highlights their really low environmental footprint compared to traditional feed crops.
Okay, give me the highlights.
We're talking lower greenhouse gas emissions, less ammonia release, which is better for air and water quality.
Better feed conversion, too. They're more efficient.
Yes, a better feed conversion ratio, less feed needed to produce the same amount of body mass, plus they need less land and water than growing, say, vast fields of soybeans.
That's quite a list of advantages.
It really is. And there's another layer which is really fascinating.
Go on.
They can be fed on food waste.
Oh, wow. So they tackle 2 problems at once, feed and waste.
Exactly. They essentially upcycle waste into a valuable protein resource. The paper does note that in Indonesia, where this study happened, they're used more in aquaculture, feeding fish, than poultry right now.
Even though they have this great potential as a protein source like soybean meal or fish meal.
Right. There's still room for growth in their use for chickens there.
Okay, so we have the sustainable, nutrient-dense insect. Now, let's bring in player number 2. Propolis. What exactly is that?
Propolis is quite remarkable stuff. The paper describes it as this sticky, gummy resin.
Resin, like from trees.
Exactly. Honeybees collect it from tree buds, young shoots. Think of it as the bee's natural construction material and antiseptic for the hive.
They use it to seal cracks and keep things clean.
Yeah, it protects the hive from infection. And what's really key for this study are its known properties.
Which are?
Strong antibacterial, antifungal, and even antiviral effects. It's potent stuff, naturally.
Okay, that definitely sounds beneficial beyond just basic nutrition. So why add that to chicken feed? What was the rationale?
That's a really important point. The paper explains that disease is a big challenge in poultry farming in Indonesia and elsewhere.
Which often leads to using antibiotics, right?
Unfortunately, yes, often routinely. But there's growing concern about antibiotic resistance. Plus, Consumers want poultry raised with fewer drugs.
So they needed natural alternatives.
Precisely. They needed something natural that could offer similar protection. Propolis, with its known antimicrobial punch and history of safe use in humans, seems like a logical candidate.
A way to potentially cut down on antibiotic use in chickens.
That was the hope, yeah, with potential benefits for public health too, reducing overall antibiotic pressure.
Okay, makes sense. So we've got the eco-friendly larva and the potentially health-boosting propolis. How did the researchers actually test them together? What did the experiment look like?
Right, the setup. They
Okay.
took 40 male broiler chicks, just a day old,
Tiny things.
very tiny, and they randomly split them into 4 different groups. Each group got a specific diet for 35 days.
So they could compare the effects directly.
Exactly. It's a standard controlled experiment design.
And what were those 4 diets? Let's break them down.
Okay, group 1, called P0, was the control. They just got 100% standard commercial feed, the basal diet, and plain water. Simple baseline.
Got it.
Group 2, P1, also 100% basal diet, but they were given a 3% propolis extract orally, so propolis only.
Okay.
Group 3, P2.
Mhm.
This group had their standard feed partially replaced. It was 85% basal diet, and the other 15% was black soldier fly larva powder and just plain water.
So BSFL only.
Correct. And finally, group 4, P3. They got the same feed mix as P2, 85% basal,
Right.
15% BSFL powder, but they also received the 3% propolis extract like group P1.
Ah, so P3 was the combination group? BSFL plus propolis?
Exactly. Control, propolis alone, BSFL alone, and the combo.
That seems like a really clear way to test the individual effects and any potential synergy. What were they actually measuring on these chicks?
They tracked several key things. Growth performance, obviously weighing them weekly, measuring carcass weight at the end.
Makes sense.
Then meat quality. They looked at the breast meat, measuring water content, crude protein, and crude lipid, which is basically the fat content.
Important for consumers.
Definitely.
Yeah.
And lastly, they did blood tests.
What did they look for in the blood?
Things like red and white blood cell counts, hemoglobin that carries the oxygen, and hematocrit, the percentage of red blood cells. These give insights into the chicken's overall health.
Okay, comprehensive. So let's get to the results. What happened? How did the diets affect growth and the meat?
Right, the findings. Interestingly, the highest total weight at the end, at 35 days, was seen in the P3 group.
The combo group, BSFL and propolis.
That's the one. It suggests there might be some beneficial interaction happening there for growth.
Interesting. What about carcass weight?
The paper noted that the groups getting BSFL, so P2 and P3, tended to have slightly heavier carcasses. But the difference wasn't statistically significant.
Meaning it could have just been chance?
Possibly, yes.
Yeah.
Not a strong enough difference to say for sure based on this study alone.
Okay, so a slight hint towards better weight with the combo. What about the meat itself? Any big differences there?
Yes, this is where things get quite interesting. The breast meat from the P1 group, remember, that's propolis only.
Yeah.
It had significantly the lowest fat content.
Oh, leaner meat. People often want that.
Exactly. And on the flip side, the P3 group, the combo again,
What about them?
they showed the highest amount of crude protein in their breast meat.
Wow. So lower fat with just propolis, higher protein with both BSFL and propolis. Those seem like pretty positive outcomes.
They really are noteworthy findings, yeah. Potential nutritional advantages depending on the diet.
How did the researchers explain these results? What did they think was going on?
Well, they linked it back to the known properties of the supplements. BSFL are rich in nutrients, protein, fats.
The building blocks.
Right. A good source of energy and amino acids for growth, muscle development. And they also pointed to other studies that hinted propolis could positively affect body weight in poultry.
So it lines up with their P3 group doing well overall.
Seems to, yes.
Mm-hmm.
The larvae provide raw materials. Maybe the propolis helps with overall health or efficiency.
Okay, that makes sense. Let's shift to the blood results then. What did that analysis tell them about the chicken's health?
The blood work had some really interesting, maybe even slightly unexpected findings. First off, red blood cells.
Important for oxygen.
Crucial. But they found the counts weren't significantly affected by any of the diets.
Really? No difference.
Not a statistically significant one. They actually noted this differed from some other research.
Why would that be?
They suggested maybe differences in the environment or the exact type of basal diet used in various studies. It just highlights that these things can be complex, more to learn.
Yeah, science is rarely simple. What about white blood cells? They relate to the immune system, don't they?
They do, a key indicator. And here they did find a significant difference.
Which group?
specifically in the P3 group, again the combo of BSFL and Propolis. Their white blood cell count was significantly higher.
What does that suggest? A stronger immune system.
It suggests a stimulating effect on the immune system, potentially making those chickens better equipped to fight off infections.
That sounds really positive, especially if you want to reduce antibiotics.
Exactly. And interestingly, they also mentioned this contradicts some other studies where propolis alone didn't significantly affect white blood cells.
So maybe it's the combination again, a synergy.
It points that way, doesn't it? Another hint that BSFL and propolis together might be doing something special for immunity.
Okay, boosted immune response. What else did the blood work show?
They measured hemoglobin, vital for oxygen transport. And here they saw a significant improvement in hemoglobin levels in both the P2 group,
BSFL only.
yes, and the P3 group, the combo.
So adding BSFL seemed to help with hemoglobin.
It looks like it. This is a really positive finding because it suggests BSFL could help prevent anemia, which can be a problem in poultry.
Good news. Anything else from the blood tests?
Just hematocrit levels the proportion of red blood cells. They found no significant effects there. All groups were within the normal, healthy range.
So including DSFL didn't mess with that aspect of blood health.
Correct. No negative impact seen there.
Okay, so let's piece the blood findings together. No major change in red cells overall, but a potential immune boost, higher white cells with the BSFL propolis combo,
Right.
and better hemoglobin, maybe fighting anemia when BSFL was included.
That sums it up pretty well. A fairly positive picture, health-wise.
So taking everything into account, growth, meat, blood, what was the study's bottom line? What did the researchers conclude?
Well, pulling it all together, the paper concluded that using BSFL as a partial feed replacement, especially when combined with propolis, gave satisfactory results.
Satisfactory across the board, performance, carcass, meat, quality.
Pretty much, yeah. The chickens grew well, the meat had good qualities, and importantly, that combination seemed to improve the bird's overall health status.
So a thumbs up for the approach.
Definitely. They suggested it's a really promising strategy, particularly for developing the local poultry industry using local resources.
Right. Using things readily available, like BSFL grown on waste and local propolis.
Exactly. It highlights the potential for these local resources to build a more resilient and environmentally sound poultry system.
Okay, we've really dug into this study. If you had to pick one key takeaway message from our whole discussion, what would be?
The single most compelling thing for me. It's the potential power of that combination. BSFL and propolis together.
Not just as replacements, but something more.
Yes, potentially a synergistic approach. It could enhance performance and meat quality while also helping us cut back on environmentally costly feed and maybe even reduce antibiotic use. That's huge.
A solution hitting multiple targets.
Exactly. Benefits on several fronts.
And for someone listening, maybe they're in the food industry, maybe just environmentally conscious or curious about their food, why should this matter to them?
Well, it matters because it offers a glimpse, into a possible future for food production, one that's more sustainable.
And maybe leads to healthier food.
Potentially, yeah. If strategies like this scale up, we could see less environmental damage from meat production and maybe, just maybe, access to meat with better nutrition, fewer worries about antibiotics.
No, it connects to the planet's health and maybe our own health, too.
Absolutely. It's relevant on both levels.
That is a really important connection. Okay, as we wrap up this deep dive, what's a final question or a thought the study leaves you with? Something for listeners to mull over.
I think the big lingering question is about scale, really. Could adopting these kinds of alternative feeds truly transform the poultry industry globally?
Moving from promising study to widespread practice.
Right. What more research is needed? What about real-world farm trials? Can it be made practical, economical, on a massive scale?
Big questions.
They are. It makes you think about innovation in our food systems, doesn't it? How we balance feeding the world with protecting the planet.